In this next example, notice that we have mixed numbers we're subtracting, and they happen to have different denominators. So we need to find a common denominator first. And before I start solving this problem, I just want to point out that if you don't know what a greatest common factor is, a least common multiple is, how I rewrite these fractions when I end up, you'll see multiplying the top and the bottom by the same amounts. Make sure you watch the videos in the beginning of this section of the worksheet because it's going to go over those details. So if I go over something like that, what's the least common multiple, greatest common factor, watch those videos and I'll go over that in more details there. So for this one, I look at 9 and 6. My least common multiple for 9 and 6 is actually going to be 18. So to make this 6 into an 18, I know I got to multiply by 3, and I'll do the same to the numerator. And then to make this denominator into an 18, I'll multiply it by 2, and I'll do the same to the numerator as well. So again, watch the video, and I'll explain why you got to do the same thing to the top and the bottom. Now next, I'm going to simplify 6 and 8 over 18 minus 2 and 15 over 18. So now you can see we have common denominator. Now, in this problem is interesting because you notice that if I were to subtract 8 minus 15, I'm going to end up with a negative number. But when we're working with mixed numbers, we don't want the numerator to be negative. So there are a couple different approaches that you can do. But the way I like to do it is I'm going to set it up so that this number becomes bigger than that one. And before I rewrite this, I'm going to show you a similar example using visuals so you can kind of get a better idea as to how it works. All right, so if you look at this example here, it says we're going to do 2 1/3 minus 2/3. So I'm going to put 2, 1, 2. This is 2 1/3. And I'm going to take away 2/3. But if you notice, there's only 1/3 I could take away. So what I need to do is rewrite one of these, right? I don't have, like the 1/3 is, if I were to subtract 2/3, I'm going to end up with a negative amount because I don't have enough thirds. So what I'm going to end up doing is I'm going to rewrite the 2 here in 2/3. So I'm going to take one of these and I'm going to split it into thirds. So that's 1, 2, 3. Let me just rearrange this real quick. So we have 1, 2, and 3. So now you can see I took it and rewrote it into thirds. So now the 2 1/3 is actually now, let me bring it down here, we have 1 4/3. 1 4/3. So let me just break that down how it came out to be. So we had 2 1/3. And I took the 2 whole amounts and I split it up so that we're left with 1 whole amount. And then plus the 3/3, right? So let me just break it down so you can kind of see so far. So we could consider it, 2 was the same as 1 plus 1. So we had 1 and then another 1 1/3. And what I ended up doing was I took this extra whole amount over here. Actually, let me just put a plus sign here because if you add them up, you still get the same thing. This is 1 whole amount plus another whole amount plus another third. So I have that here. But then I took this whole amount here and I actually divided it into thirds. So I took one of the whole amounts and I put it into thirds. So it became like that, 1 3/3 plus another third here. And now you can see if I combine this all together. So let me combine that all together. Whoops. Just move this down a little bit. All right, now you can see, look, if I were to combine the thirds, now I end up with 1 plus the 4/3, 1 4/3, which gives me, again, 1 4/3. So again, you can see here that 2 1/3, which we started with, we actually have 1 whole amount and 4/3 if I'm looking at just the thirds. So these are equivalent. And now that I have 1 4/3, I can actually take away 2/3 now. So I could take away 2/3 because 4/3, right? So I go back here, and if I take away 2/3, if I take away one of these, and then I take away one more, you can see I'm left with 1 2/3. So going back here, I'm left with 1 2/3. So that'll be my final answer. So in this case, I don't have enough here, so I'm going to make this bigger by rewriting this mixed number. So I'm going to do the work on the side. So hopefully that visual explanation gives you a little bit of better insight as to what I'm doing here. So look, I'm going to split up the 6 into 5 plus 1. So 5 plus 1 is the same thing as 6. And then I still have that 8/18. But I'm actually going to split that up one more time. So 1 and 8/18 is the same thing as 1 plus 8/18. And remember, in math, we can do whatever we want as long as the new expression is equivalent to the original, right? If I add this all together, I get back 6 and 8/18. So I have no problem doing this. And now I'm going to rewrite this one so that it has the same amount of slices as this one. So I look at this number here, and I say this has 18 total slices. So I'm going to make it out of 18. I'm going to rewrite the other one, 8/18. So the question is, how many out of 18 do I need so that it's one whole amount still? Well, I need 18 out of 18, right? 18 out of 18 is the same as one whole amount. And now I can combine these two fractions together, and I'll get 5 plus 18 plus 8 is 26. And then 5 plus 26/18 is 5 and 26/18. So I can use this to replace this fraction here. So 5 and 26/18 is the same thing as 6 and 8/18. And then I bring down my 2 and 15/18. And you can see now we actually have enough to subtract these fractions so that my numerator will remain positive. So next I will subtract the whole amounts. 5 minus 2 is 3. And then next, I will subtract the fractions, right, over the same denominator. So I could, since they have the same denominator, I could do 26 minus 15 over the same denominator. And then we're going to get 3, and 26 minus 15 will give me 11/18. So that'll be my final answer there. And let me show you one more way that you can do this. So there's several other ways you can do it, but I'm going to show you one more way that you might like as well. So going back to the same process as before, finding the common denominator, I'm just going to do, right, the same thing as before. So I'm going to multiply this by 3 and 3 and 2 and 2, right, because that'll give us my least common denominator. So I'll get 6 and 8/18 minus 2 and 15/18 as we did before. And one thing you can actually do is, I said we don't want to have a negative numerator, but if we were to subtract it right now, we would get 8 minus 15 is -7. So now, again, I said before, you cannot leave this as a negative. A mixed number can not have a negative numerator. So what we can do is that this expression, or this fraction, is the same thing as saying 4 plus -7/18, right? These are equivalent right here. And now, since I have that written this way, 4 plus -7/18, that's the same thing as just saying 4 minus 7/18. It's the same exact thing. And now I just have a whole number minus a fraction. And what I do here is I'm going to write this as a fraction. So I'm going to put it over 1 because 4 divided by 1 is still 4. And now I need a common denominator. And the common denominator would be, for this one, 18. Right? So I multiply this by 18, which means I got to do the same to the numerator here. And then when I simplify, I get 4 times 18 is 72, and then minus 7/18. And now all I got to do is subtract these two since they have the same denominator. I can put the numerators over the same denominator. And then when I subtract this out, I get 65/18. And this is my improper fraction, but if they tell you to write it as a mixed number, then you would have to write it as a mixed number. And to write this as a mixed number, all I have to do is figure out how many 18s go into 65. And what I do is this process. I like this process because you can kind of see, there's like shortcuts you could do, but I like to see why those shortcuts work and have you figure out what the shortcut is. But basically, how many 18s go into 65? Well, I have one amount, right, because 18 out of 18. Because remember, the denominator tells you the most number of slices you can have. So you can have at most 18 out of 18 before it becomes improper like this. So I'm going to keep repeating this pattern until I can get as close to 65 as possible. So far, you can see when I add these two, so far I have 36. So I can actually do another 18. And 36 and 18 would give me, let's see, 36 and 18. Quick little side note, that's 46. And that'll give me 54 there. So that means I could do another 18 in there. If I do another 18, I get 12/72. So that's actually too much. So we're going to leave that there right now. And I just got to ask myself, how many more are left? So when I add all these together, I get back 65. And when I added these here, I said we get 54. And we're trying to get the 65. So I just say, okay, how many more are left to get the 65? When I subtract this out, I get 1 and 1, 11 more left. So I could take this out and put an 11 there. So when I add all these together, I get back 65/18. And now notice that 65/18 is the same thing as this is one whole amount plus another whole amount plus another whole amount plus the remainder of 11/18. And now I just simplify it all. 65 out of 18 is 1, 2, 3. and 11/18. And you can see here, 3 and 11/18, we did a different method. If I were to go back to the original method that I showed you earlier, we got the same answer. And that's another thing to point out, that when you're doing mathematics, if you could get the same answer doing two different, totally different methods, it's a good way to check your work to see if it is correct.